Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the first part of the series of CSIR NET physics 2022 papers solution series. Okay, so and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Many courses I have completed, so for watching all the detailed courses I would suggest you please check my YouTube channel's playlist. You will get all detailed courses there, and those courses are going to help you a lot. Okay, so let's get started. So today onward I'm going to solve CSIR NET Physics 2022 paper. Okay, so I'm going to start now. Okay, so the first question is the value of the integral the integral the value of the integral. The integration is given, that is 0 to infinity 0 to infinity uh, dx e to the power uh, x e to the power x to e to the power minus x to the power 2m. Okay, so this is what given, e to the power minus x to the power 2m, where m is a positive integer, where m is a positive integer positive integer integer is. Okay, so this is the question and options are given. First option is gamma m plus 1 upon 2m. Okay, gamma m plus 1 upon 2m. Option B is gamma m minus 1 upon 2m. Okay, and option C is gamma m minus 1 no, it's not m minus 1, it's gamma 2m plus 1 2m plus 1 upon 2m. Okay, and option C is gamma 2m minus 1 upon 2m. Okay, so these are the options, guys. Okay, so these are the options. Just let me check whether I'm audible or not. After that I'll proceed further. Just let me check whether I'm audible or not. After that, yes, I'm audible, so I'll proceed further. So this is the question, guys. So value of integral. So this integral is given 0 to infinity dx e to the power minus x to the power 2m. Okay, where m is a integer, positive integer is okay. So this integral value we need to find out. Okay, so I will solve now. Okay, guys. It's an easy question, and I'm going to solve it. Okay, so first I'll write this value which is given. Okay, integral I, that is integration 0 to infinity 0 to infinity dx e to the power minus x to the power 2m. Okay, so this is the integration which is given, guys. Okay, okay, so what we can do is m dx, right? Let's say uh, m equal to 1. Okay, we are taking taking m equal to 1, taking m equal to 1. Okay, and m is integer, right? So this value I is going to be integration 0 to infinity, and this is going to be e to the power minus x square, e to the power minus x square. Very simple question, guys. E to the power minus x square dx, right? Because we have taken m equal to 1. So now there is a formula, guys, we know, right? We have a formula. I have explained that formula in my mathematical physics lecture, so you can watch that. This detailed course of mathematical physics I have completed in 36 lecture. You can watch all the lectures in the playlist, okay, which is available in the playlist, and those lectures are absolutely free of charges. Okay, so you can watch it at any time. Okay, so there is a formula, guys. This is we know that is minus infinity to plus infinity uh, e to the power minus alpha x square. Okay, so this the answer of this is root pi upon alpha. I told you it's a very important formula and you need to note down and memorize it, guys. Very important formula. Okay, so e to the power minus alpha x square integration minus infinity to plus infinity e to the power minus alpha x square equal to root pi by alpha. Okay, so but we need this one, right? So here alpha is 1. So it means integration 0 to infinity. It's a given function. So 0 to infinity e to the power minus alpha x square. This value is going to be 1 by 2 root pi by alpha, right? We have broken the limit, right? This one. For this is going to be this one. Okay, so this is important formula. You need to note down, guys. Now what we are going to do is we'll just use this formula, right? So this I value is going to be value of I is going to be this one. Here this is e to the power minus x square e to the power minus alpha x square, right? So here alpha is 1, right? So this is going to be same 1 by 2 root pi upon 1, right? So I is going to be 1 by 2 root pi upon 1, right? Or this is going to be, we have used this formula, guys. Integration 0 to infinity e to the power minus alpha x square is values 1 by 2 root pi by alpha. Okay, so this one, right? So this value is going to be 1 by 2, that that integral value is going to be 1 by 2 root pi. Okay, so 1 by 2 root pi, right? So this is the this is for m equal, when we have taken m equal to 1. Okay, now we will check we will check by option, guys. Okay, so we can check all the option, right? We can we'll put m equal to 1 here. We'll put in option. Okay, m equal to 1. If this value give, if I will be equal to this, in that case that option will be the correct option. Okay, so if we check all the options, so if we check option C, I'm directly checking this. Okay, option C. So option C is gamma 2m plus 1 upon 2m. This one, 2m plus 1 upon 12. Okay, so we are going to we are putting m equal to 1. Okay, this is going to be gamma 2 into 1 plus 1 upon 2 into 1. Okay, so this value is going to be gamma 3 by 2. Gamma 3 by 2, we know we have a formula. This formula, guys, I'll write here as well. I'm writing formulas in red. So this is that gamma n plus 1. Gamma n plus 1 is going to be n gamma n. Okay, so here we'll use the same thing. So this we can write this. This means, this implies gamma 3 by 2. We can write gamma 1 by 2 plus 1. We can write, right? 1 by 2 plus 1 is 3 by 2. And we'll use this formula, gamma n plus 1 equal to n gamma n, right? So this is going to be n, here n is 1 by 2. 1 by 2 gamma 1 by 2. And gamma 1 by 2 value is pi, guys. I hope you know it. Okay, so then it means, this means this is going to be 1 by 2 root pi. 1 by 2 root pi. 1 by 2 root pi. Okay, so you can so 1 by 2 root pi. 1 by 2 root pi, and we know gamma half value is root pi. Okay, so you can see in option C, if we are putting m equal to 1, we are getting the same answer, that is I, that is 1 upon 1 upon 2 root pi, right? So it means option C is the correct option, because if you are putting m equal to 1, we are getting the same answer, that is 1 by 2, right? So very simple question, guys, and very good question, formula based question. Okay, so here what we have to do is we are just putting m equal to 1. Okay, and then we'll get this this integral, and this integral form, we know how to solve it, right? There's a formula. So with the help of formula we have solved it, and we've got this value, and we have checked by option. So in option C we have seen, if we put m equal to 1, we are getting the same answer, right? So it means option C is the correct option, guys. This is the correct option. Okay, so this is this gamma 2m plus 1 upon 2m. Okay, next question. Question number 2. Question number 2 is question number 2 is, at z equal to 0, at z equal to 0, the function at z equal to 0, the function function 1 upon z minus sin z, 1 upon z minus sin z of a complex variable, of a complex variable, of a complex variable, of a complex variable z has, options are option A, no singularity, no singularity, no singularity. Option B is a simple pole, a simple pole. Option C is pole of order 2, a pole a pole of order 2, a pole of order 2, and option D is a pole of order 3, a pole of order 3. Okay, so this is the question, guys. Okay, 3.5 mark question. Okay, so at z equal to 0, the function we have been given, that is 1 upon z minus sin z of a complex variable z. Okay, of a complex variable z has, options are no singularity, a simple pole, or a pole of order 2 and a pole of order 3. Okay, so this is the question. Simple question. I'll solve it now. So, okay, so we have been given this function, right, fz, that is 1 upon z minus sin z. Okay, so this is the uh, function which is given. Okay, now this is the one, right? Or we can write, this implies one upon z sin z. This we can write like this. Okay, we can open sin z, expand sin z. Okay, so z minus, and sin z we know how to open it, right? This is z minus z cube upon 3 factorial plus z5 upon 5 factorial plus z7 upon 7 factorial plus so on. Okay, so this is the expansion of sin z. I hope you know it. Okay, so this is the expansion of sin z. Sin z is z minus z cube by 3 factorial plus z5 upon 5 factorial minus z7, z to the power 7 upon 7 factorial. Okay, so this implies we can write, this is 1 upon z minus z plus z cube upon 3 factorial, okay, plus z5 plus minus minus. Okay, this will be minus sign, minus z5 upon z to the power 5 upon 5 factorial and plus z to the power 7 upon 7 factorial plus so on. Okay, z will get cancelled, right? So it means the value is going to be 1 upon z cube upon 3 factorial minus z5 upon 5 factorial plus z7 sorry, z to the power 7 upon 7 factorial, okay, plus so on, this one. Okay, so this is the one, right? So it means this we have got, it means that implies at z equal to 0, if you put z equal to 0, there is a pole of order 3. There is a pole of order 3. There is a pole of order 3. Okay. So there is a pole of order 3. So you can see. So at z equal to 0, put z equal to 0. So there is a pole of order 3. Okay. So which option is matching, guys? Order 3. Which option is matching? Okay. So option D is the correct option, guys. A pole of order 3. So very good question, right? And very simple question. Okay. What we have done is we have just opened the that sign, expand the sign z, and got the value and put z equal to, at z equal to 0, we have seen is a pole of order 3. Next question. Question number third. Question number third. Okay. Question number third is question number third is 2 n cross n. These are 2022 paper questions. Okay. 2 n cross n, 2 n cross n invertible 2 n cross n to n cross n invertible real matrices, invertible real matrices, invertible real matrices A and B, A and B, A and B satisfy the A and B satisfy A and B satisfy the relation AB to the power AB transpose of AB, that is equal to minus A inverse B whole inverse. Okay, B whole inverse. Okay, if B is orthogonal, if B is orthogonal, if B is orthogonal, then A must be, then A must be, options are given. Okay, A must be, option A is that is lower triangular lower triangle lower triangle option B is orthogonal option C is symmetric option C is symmetric, and option D is antisymmetric. Antisymmetric. Okay, so this is the question. Okay, so I'm going to explain this question first. Okay, very simple question from matrix. Okay, so two n cross n non-invertible real matrices. Okay, so we have been given two real matrices A, B. Satisfy this relation. This relation we have been given transpose of A equal to minus A inverse B whole inverse, right? If B is orthogonal, A must be. So options are given: lower triangle, orthogonal, symmetric, and antisymmetric. Okay, B is orthogonal given. Okay, so I'm going to solve it. Okay, so okay, so what we have been given, I'll write it: A B transpose of A B given transpose of A B, okay, equal to minus A inverse B, A inverse B transpose of A inverse B, sorry, inverse of A inverse B, right? This is what given. So, so now we can open it, right? So we know the formula, right? AB transpose means is a property of matrix, right? AB transpose means B transpose of B transpose of B and transpose of A, that is equal to uh, inverse of A inverse B is going to be minus B inverse A inverse whole inverse, this one, because we know the property, right? Transpose of AB is B transpose A transpose, okay, and also inverse of AB is B inverse A inverse, okay. So this means this is going to be B transpose A transpose, okay, B transpose A transpose, okay, this one, and this is going to be equal to minus B inverse A inverse inverse is A inverse inverse is A, and here guys also it is given B. B is orthogonal. It is given B is orthogonal. Okay, B is orthogonal. Since we have been given B is orthogonal, this means B is orthogonal means B transpose equal to B inverse. Okay, this you need to understand. B transpose equal to B inverse, because B is orthogonal. So B is orthogonal means transpose of B is equal to B inverse. So in place of B inverse, we can write in place of transpose of B, we can write B inverse. So this is going to be B inverse A transpose or transpose of A equal to minus B inverse A. B inverse will get cancelled. Okay, so transpose of A is going to be minus A. Okay, this is the condition. This is the condition of if a transpose of A equal to A, then that matrix is called symmetric matrix, right? This is a property. If transpose of A is minus A, then it is antisymmetric matrix, right? This implies this is antisymmetric, antisymmetric, antisymmetric matrix, antisymmetric matrix, okay? Because transpose of A is minus A. Okay. So which option is matching, guys? Option D. Option D is the correct option. Okay. I hope you have understood it. Next question, I'm going to solve it. So next question is good question. Question number 4. Question number 4 is the infinite series. It's a good question, guys. Okay, the infinite series, the infinite, the infinite, the infinite series, the infinite series, that is sigma n equal to 0 to infinity n square plus 3n plus 3n plus 2, okay, plus 2 into x to the power n. Okay, so the infinite series, this evaluated at evaluated evaluated at x equal to half is, options are option A, that is 16, option B, that is 32, option C, that is 8, and option D, that is 24. Okay, so this is the question, guys. Let me solve it. Okay, guys, just give me 1 second. Okay. Okay, guys. So this is the infinite series we have been given. Okay. So sigma n equal to 0 to infinity n square plus 3n plus 2 x to the power n, evaluated at x equal to half. Okay. So we need to evaluate this at x equal to half. Okay. And that value we need to find out. Very good question. So there's a formula, guys, which you need to know first. Okay. Okay. So we have been given this one, right? This is sigma n equal to 0 to infinity n square plus 3n plus 2 n square plus 3n plus 2 x to the power n. Okay, that we need to find out. Okay, so here we have a formula. The formula is this one: sigma uh, n equal to 0 to infinity x to the power n, n equal to 0 to infinity x to the power n. This value is 1 upon 1 minus x. Okay, this you need to know down. Okay, this formula: sigma n equal to 0 to infinity x to the power n. This value is 1 upon 1 minus x. This you need to note down and memorize it, guys. Okay, now we can easily solve this one. Okay, so what we are going to do, so this we know, right? So we can differentiate it with respect to x. Okay, so if you differentiate it with respect to x, then this is going to be sigma n equal to 0 to infinity and this is n x to the power n minus 1. This is going to be, we are going to differentiate it, so this is going to be 1 upon 1 minus x whole square, right? Because if we will take this denominator in numerator, this term in numerator, right? And then that is going to be whole to the power minus 1, and then this is going to be whole to the power minus 2, and again we'll differentiate this. This is simple differentiation, guys, and you know it, right? Simple one. So this is the value. Okay. Now again, what we or we can write this one. Okay. What we can do is we can multiply this by x. If you multiply this by x, then this is going to be n equal to 0 to infinity. Okay. And this is going to be n x to the power n, because we are multiplying with x, right? Then x into x to the power n minus 1, that is going to be x to the power n, and then this is going to be x into 1 minus x square, 1 minus x square. Okay. Let's say this is as equation number 1, this is as equation number 2, as equation number 2. Okay. Now again, what we are going to do, again we are going to differentiate this equation 2 with respect to x. Okay. So if you again differentiate it, then this value is going to be n into n square x to the power n minus 1, right? So this is going to be sigma n equal to 0 to infinity n square x to the power n minus 1, n square x to the power n minus 1, and this will differentiate. Okay, this is there are two terms, right? Numerator and denominator. So we'll use this. We'll differentiate this with numerator and denominator property, right? So this is going to be simple. That is 1 upon 1 minus x whole square, right? This one. This is first function. This is second function, right? Or this is second function differentiation of first, right? And then first function differentiation of second. This is 1, and then this is going to be plus first function, and differentiation of second is going to be minus 2 into 1 minus x to the power minus 3. Okay, and this value is going to be 1 upon 1 minus x whole square. Okay, and plus 2x upon 1 minus x whole cube. Okay, this one, and here is also minus 1, right? Minus minus plus, so 2x upon this 1 minus x to the power 3. Okay, because it is 1 minus x to the power minus 3, it will come in denominator and it will become 1 minus x to the power 1 minus x to the power 3. Okay, so this is the value of this sigma n equal to 0, n equal to 0 to infinity n square x to the power n minus 1. Okay, next. Now what we can do is, again we can this one, we can solve it further. Okay, so if we solve it, this is going to be, we can take 1 minus x cube as a common. So this is going to be 1 minus x plus 2x, right? So 1 plus x, 1 plus x. This value is 1 plus x, 1 plus x upon 1 minus x cube. Okay. Now what we can do is, again we can divide it. We can multiply this with x. Okay, because for making x to the power n. Okay, so this is going to be sigma n equal to 0 to infinity n square x to the that we have multiplied this by x, right? So x to the power n, x to the power n minus 1 into x means x to the power n, right? So this is going to be this is going to be this one this one. Okay, so this is going to be x into 1 plus x, x into 1 plus x upon 1 minus x. Okay, so n square x to the power n value is this. N square x to the power n value is this. Okay, now we need to find the value of this, right? This one. So we can write it. So that implies sigma n equal to 0 to infinity, n equal to 0 to infinity, n square x to the power n plus 3n x to the power n plus 2n x to the power n, right? This value is going to be this value, and this sigma n equal to 0 to infinity n square x to the power n value is this. This is equation number 3, we can say, right? This value is this. So we can write x into x plus 1, x into x plus 1 upon 1 minus x whole cube, right? This one. Now second is 3n, this is sigma, right? This is sigma for this. Sigma 3n 3n x to the power n x to the power n value is this, n x to the power n, this one, x upon 1 minus x square, right? This is going to be 3, this sigma n equal to 0 to infinity, n x to the power n value is, we have got here, right? x upon 1 minus x whole square, okay, plus 2 sigma n 2 sigma n equal to 0 to infinity n x to the power n, from equation n x to the power n is this. Okay, this one, x to the power n, right? This is n. It is not n, guys. It is just a 2x, because this is the question, right? This one, just 2. Okay, so 2x to the power 2x to the power n. So sigma 0 to infinity x to the power n value is this one, 1 by x. So this is going to 2 upon 1 minus x, right? So this value is this. Okay, so we can take x common, so we'll get the same thing, right? N square sigma n equal to 0 to infinity n square plus 3n plus 2 x to the power n, right? So now we can so now at x equal to half, because we need to find out at x equal to half. If you put the value of half here, this is going to be half into half plus 1 upon 1 minus half whole cube plus half upon 1 minus half whole square. Okay, this is 3, guys. Okay, 3 by 2, let's say 3 into half, 3 into half, and plus 2 upon 1 minus half. If we calculate it, this value we are getting 16. Okay, 16. So which option is matching, guys? 16. Option A. So very good question, guys. This is the series. So we just need to know this one. Sigma n equal to 0 to infinity x to the power n is 1 upon 1 minus x. Okay, then we'll differentiate it. We'll get this value, and again we'll differentiate it. We'll get this value. Okay. Also will multiply by x, right? And after that we just put the values of this value, this value, this value, and after that we'll put x equal to half. We'll get the answer. I hope, guys, you have understood it. Next question. Next question is, these are simple questions. Okay, this is a good question, guys. So you need to practice this question. Okay. Next question is question number 5. Okay. Question number 5 is question number 5. This is it's a simple question, guys. If equal to I to the power, I mean iota to the power iota to the power iota iota to the power iota and so on. Okay, so z equal to iota the power iota the power iota iota the power iota the power iota and so on. Okay, this it is written, note that it is written, note that the exponent the exponent the exponent continues 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 indefinitely. Okay, note that the exponent, this exponent continues indefinitely. Okay, that's infinite. Okay, indefinitely. Then then a positive value, then a positive, then a positive value of positive value of 1 upon z ln z, 1 upon z ln z is, okay, 1 upon z ln z is, options are given. Option A, that is 2i ln i 2i ln i. Option B is ln i. Option C is I ln I ln I, and option D is 2 ln I 2 ln I. Okay, so this is the question. Very good question. Okay, if z equal to iota to the power iota to the power iota to the power iota and so on. Okay, then positive value of 1 upon z ln z is, okay, so we need to find positive value of 1 upon z ln z. Very simple question. Okay, I'll solve it now. Okay, so we have been given z equal to iota to the power iota to the power iota and so on, right? This is given. Okay, we can write like this. Okay, we can write z equal to iota to the power z, iota to the power z, because this is infinite series, guys. Okay, if it is infinite series, so this is iota to the power iota to the power iota, it's infinite series, right? So if we leave this term, this series also going to be infinite, right? So so we can leave this term, and we can, this is also iota to the power iota to the power iota iota to the power iota so on till infinite, right? So we can write this term as z as well, right? I hope you have understood it. Because suppose we know the ocean, right? If we take one glass of water from the ocean, that is not going to affect the ocean, right? So same thing is here. Okay, so so we have left this term, and again iota to the power iota to the power iota so on, that is also going to be z. Okay, so this one now very simple, we'll take ln in both sides. So this is going to be ln z is going to be this is z ln I, z ln I, right? Simple, we have taken ln z, and this is ln I to the power z, right? And that property, okay, I'll write this as well. So we have taken ln iota to the power z. Okay, so we'll use ln log property. So this is going to be ln z equal to z ln I, or we can write, this implies ln z upon z, or 1 upon z into ln z, that is going to be ln I, right? So ln I is the answer. So that's what we need to find out right here. 1 upon z ln or ln z upon z values. So this value is going to be very simple question, right? We have solved this question within a minute, right? So this is 3.5 marks question in 2022. Okay. So here, so value of this is ln I. So which option is matching, guys? Option B is the correct option. Ln I, option B. Okay. I hope, guys, you have understood it. Okay. So, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. After this class, I'm going to solve 2023 paper. Okay. So this is the first part of the series of physics 22 paper solution. Okay. Okay, guys. So also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, and which are going to help you to crack the exams related to physical science. And also, guys, I would request you. Also, guys, I would like to tell you that many detailed courses I have completed. So please check my playlist. In the playlist, many details courses are there, so you can watch those courses as well, because those courses are going to help you. Okay, so after this class, I'm going to solve December 2023 paper, and after that I will solve June 2023 paper. Okay. Okay, guys, thank you so much. Bye now.